welcome everyone. Welcome to our Jameel Clinic seminar series. Like every Wednesday from 4 to 5, we've been doing this for a few months, and we have our PIs showcasing their work. Today, we're going to have Kalyan Veeramachaneni. Kalyan is a principal research scientist in the Laboratory for Information and Decision Systems, LEADS. He was previously a research scientist at CSIL as well, and his primary research interests are in machine learning and building large-scale statistical models that enable discovery from large amounts of data. His research is at the intersection of big data, machine learning, and data science, and he directs a research group called Data Science, Data to AI in the new MIT Institute for Data Systems and Society. And this group is interested in big data science and machine learning, and is focused on how to solve foundational issues, preventing artificial intelligence and machine learning solutions to reach their full potential for societal applications. And Kalyan has been a very dear PI from the beginning with Jameel Clinic. He's been there since the very beginning, right, Kalyan? And yes. So we are very happy to keep having with us and doing excellent work. So today we're going to have a sample of this and what he's been doing lately. So again, the session is 1 hour. We can keep few minutes for the end of the session, but there's always like questions from attendees, guests during the session. Please feel free to text, raise your hand, chat, and we'll do our best to answer your questions. Kalyan, the stage is yours. Thank you very much for joining today.
Thank you, Ignacio, and thank you for that kind introduction. Certainly very happy to join here and very happy to talk to folks at Jameel Clinic. And as Ignacio mentioned, this project is primarily funded by Jameel Clinic, and it was very sort of a fortunate thing for us to get funding like this. I'm particularly interested about this project because of two additional axes of learning that it brings for me, that I'm personally learning so much by working on this project, which is a very different from any sort of project that is being worked on in my group. So thank you for the support, and I'm excited to present this. So the project I'm going to present today is called iBoca. We built an application for virtual cognitive testing, and I'll give you a little bit of history. There is a very interesting history behind this project that spans multiple years without me, and then some years with me. And so I'll give you a little bit of history to everyone about the project as well. So this is the team that makes it possible, the past and the present. There have been a lot of people over years that have joined the project and helped it at different stages and mature it. It is a very complex project with many moving pieces. We, at some point, had teams divided into application developers, design team, as well as the field team that actually did out in the field and got tests and collected test results. And there's a lot of challenges in doing that. That's one of the interesting learning for me personally, because it spans the gamut of, so building applications, collecting data, analyzing data, and trying to do machine learning. And we are only very preliminarily getting to the point where we can actually analyze the data and start to think about what next to do with that kind of data that we are collecting. I'm also joined by Chan Lim, who's not on the call today or on the presentation today, but he definitely is the guiding force behind this project. He's a principal investigator and a clinician in Beth Israel, who's working with us throughout this project. Seth Amir Singh, he's one of the lead of the projects who has worked on this project the longest. And there's a little bit of a history around that, which I'll share. He started this in his high school, and now he's on to college, and he continues to work on the project and leads it. So that is Seth. And Alexandra and Dongyu are part of my group, and they work on this project with me in different stages. Then I also point out a lot of folks that had joined this project and helped, especially Sana, Juhyun Lee, and Michaela. They have helped figure out how to do testing, set up the testing protocol, start collecting the data, which has been particularly interesting and challenging in this project. So all the work is done by the team. I'm here just sort of presenting, and I'm learning as part of the project as well. So the problem that we are after, and this is a very quintessential slide that we put together in almost all our presentations, which is like, how much cost is it Is it in terms of dementia, how to handle dementia, how to, there is no treatment for it, but there are ways you can help people deal with it. There are costs associated with when you try to help people deal with it. And in 2018, it was sort of estimated that there'll be $1 trillion US dollars that were being spent worldwide on this particular disease. And it's, dementia is sort of the, I believe it's the last stage of your cognitive impairment, and it goes through different stages. And it's also expected that this cost will double by 2030. So this is a worldwide problem, as well as a problem in, you know, it's a problem in almost all our lives. We can see it. I have parents that are very old, though they don't have diagnosis of AD, but I do know that they have cognitive decline, very little by little. I can see that there is some amount of decline that they have. They're in late 70s. So I can, you know, I recently visited them, so I know how they are, you know, doing on that front as well. So there's a lot of cost towards it. You know, the big problem here is that, as I mentioned, my parents have not been through testing themselves, but I can see it. I can see that they start their morning and by afternoon, they forgot what they told should be cooked. And then when they see the food, they say, this is not what we asked for. And so they change their sort of like, they forget what they had asked for even in the morning. So the problem here is that, you know, the diagnosis or even understanding the cognitive impairment early on is not happening. Is not happening as fast as we think it should be happening. And what are the reasons for that? I think the reasons for that is that there is not a single test that will just give you a quick test that will give you that, oh, you're having, or you're having an onset or an early onset of cognitive impairment. There's not a single small test or a tool that is available for anyone to do. I mean, for blood pressure, we do have ability to measure blood pressure. When you go to a doctor, it's, you know, within 5 minutes, they'll measure blood pressure, and it's a very routine thing. Since cognitive testing is not that easy and not that fast, it's not done on a routine basis. And as a result, there's lack of compliance, lack of people getting these tests done early on to figure out if there is an impairment. There is no treatment per se, but there are treatments to slow the disease progression. There's lifestyle changes that can be suggested. There's a lot of guidance on how to, once you detect there is a problem, you can suggest a lot of things. So there's a lot of ways you can help manage the disease and improve it, but there is not particularly a treatment available for this. So our goal when we started this project, and you know, when in 2014, and I'll give you a little bit of timeline, was to sort of break this cycle. Can we actually create a very easy to use test to start detecting cognitive decline early on? And it should be, if you want to make it easy and widely available, there are certain aspects of it that we have to make that will make it easy and widely available. And one of that is digitization. So the obvious question is, how is it done today? So this is the test that is being given today. It's a pen and paper test. It's called Montreal Cognitive Assessment Test, called MOCA. In this test, it's proctored. So you will have a trained professional that will try to administer tests on you if you go to the trained professional. They'll give you a sheet of paper, much like the one that I'm showing here. And there's different tests in this in the sheet of paper that you can do. Some of them are actually guided by the proctor, and some of them, there's an interaction between the proctor and the person who's taking the test. There's a back and forth. And oftentimes this will take you 30 plus minutes to take the test. And for this, you have to go to a clinical setting, or you have to go to a setting where the trained professional is available. For many of us, we understand testing when you have to say, oh, you have to go to a certain place, unless it's really urgent, you actually don't go and get the test done unless it's really required. And that's one of the reasons why people just ignore this and don't get this tested. And the easiest way to detect this is something that I have heard from some of our collaborators, the detection comes when some close family member sort of tells that there is a cognitive decline, just like how I'm telling that there may be some cognitive decline with my parents. So let's go through a few tests just to give you an example. One, these tests actually measure different functions of your brain, your ability to memorize things, your attentiveness, your language, different visual-spatial executive, which means how you can actually visually and spatially simultaneously work with a certain amount of visual paper. Here it's called Trails test, and I'll give an example what that means. But let's go through one test, a couple of tests on this pen and paper. This one is very famous, and it became famous in 2020. Many of us know this test. In this test, the trained professional will read words in a certain order. So in this case, face, velvet, church, daisy, and red, and then give some time. And after that time, the subject has to repeat them in that same order. And this is done twice in 2 trials. And the professional will write down whether you got it right or wrong. So this is called a simple memory test that you can try to test some individual with. The second test, which is the visual spatial executive function, is you have these bubbles, and your goal is to connect from 1 to A to 2, and 2 to B, and B to 3, and so on and so forth. So you have to alternate between the digits as well as the alphabets, and then you have to spatially see where they are and draw the lines and connect them. So this could be completely done on pen and paper. This particular test could be done on paper, and the trained professional will watch you doing it, and at the end, they can even try to write the time if they can record the full time. They can also record whether you got it right or how many did you get it right. Still all in the scope of pen and paper. And there's several tests on that, right? Going from naming, so you're shown certain animals and you're asked to name them, as well as the attention where you're read a certain order of numbers or alphabets, and you're asked to repeat those numbers or alphabets. And you can increase the difficulty level for some of that, as long as the pen and paper test allows you to do so. So this is how it's done. It's usually taking 40 to 45 minutes. A reasonable, you can try to get it done in 30 minutes, but it does take 40 to 45 minutes to do the test. And that is not adding all the time it takes you to get to the place and get the test and so on and so forth. So what was our solution? I have to see, sorry. So one of the things that we came up with that we probably will solve, and many people actually have come up with this solution as well, is to why not digitize this particular testing procedure? Why not make it digital so that it's not error prone, because you also have to remember that the trained professionals may also make some errors when they're taking the test. It's adaptive, so it's actually more, for the trails test, you can only limit yourself to the test that is on the printed paper. But if you make it digital, you can make the test of increased complexity. So you can have 1 to 4 and A to D versus 1 to 9 and then A to J, or some, you can expand the scope of the test, or you can make it incrementally difficult. Another advantage of that is, perhaps the biggest advantage that is of interest for all of us, is the ability to collect a lot of data in the background. And I'll show you what kind of data we have already started to collect with this application, and how we can analyze that and look for clues in that data to build tests that are shorter in time, or maybe do adaptive testing as well. So we launched this application called iBokeh. It's a digital tool. It's because it stands for iPad, so it can be administered on an iPad. Our goal was to create multiple tests and make them available through the iPad application. And then finally, in the back end, collect all the fine-grained data that we wanted to analyze or use that for further machine learning. The reason this project is, I said 2 axes that it has made me learn. One axis is obviously the healthcare aspect of it, which I shouldn't call myself having any expertise in that. I'm still learning on a daily basis as to what are the dimensions of this problem and how do you actually solve this. The second axis is that it's actually very interesting to see throughout my career, I've only relied on me being given data and then analyzing the data. And oftentimes that has limitations, and oftentimes you have to go back to the data collection system or a data collection team and request something, and those requests doesn't get fulfilled, or because they have different priorities. Their goals are to, whatever project they're working on, whatever application, they want to take that application forward rather than, enhance the data collection, if you will. So there's always been this sort of nagging feeling that I should get involved at the sort of the level where the data is being collected. And that's the second axis in this project that has been very interesting learning experience for me, that how do these systems get built, and how can we make data collection itself informed such that you can use machine learning or you can use data analytics there. There's one more challenge that became, so originally it was all about collection of data, that we will be able to collect fine-grained data. Then we realized in 2020, as you'll see, that we were not able to do proctoring of these tests, which means we were not able to stand beside the subject and guide them through the test with the application. In 2020, as everything shut down, we had to revisit the entire application design and rebuild it such that it could be self-administered. And that brought about a few more interesting nuances in terms of how we build this application and how we are going to use it going forward. So
Let me ask. Hello?
build further this application. So what does this application have? It has 13 tests. So some of the tests that we just went through, the simple memory test, as well as naming pictures, as well as trails, are all now digitally available. So there are 13 tests that are available. And then there are some tests that are actually very hard to do them in person. And I'll show you an example of what that test is. And it's actually much more easier to do that digitally than doing that in person. So these are the 13 tests that are available in iBoka as of today. They test different functions. So similar to the pen and paper test, they test these different brain functions, ranging from conceptual thinking, language, memory, as well as the visual, spatial, and visual constructional skills like the trails function. So this is a video of sort of an animation video of what the application looks like. So in this case, it's the trails test. So a person is actually drawing with their hands. They're drawing and connecting from 1 to A to where you read a bunch of numbers. So this is the kind of test where if you had a proctor or a person who's administering the test, will read out the numbers loud to you, and then you're supposed to read them back to them. So in a self-administration, we have an audio that actually reads out the numbers of different lengths. And with that, once you heard that, it takes a little bit of a break, gives you a little bit of time, and then you have to recall those numbers and enter that. So when we are doing those self-administration, converting them into self-administration tests, these are the sort of changes that we had to make. This is the one I think is hard to do in person. This is where you have these blocks, they flash in sequence and into a different color, in this case, the green color. And then once they flash, there's a few seconds gap, and then the person is asked to enter which box were highlighted as green in the same order as they were flashed before. So that's a challenge that you have to do. Now you can imagine in person, you can't do this on pen and paper. So I heard there's different ways to do this, but it actually could be error prone and could be time consuming to do this test in person. So this is called forward spatial span test. And so the promise, as I said, is obviously the data. So we have advanced data collection. We can directly now, from the app, we can directly connect to the cloud and collect it there. One other advantages is that we can store and track and create longitudinal data for a particular patient or a subject. That is actually more interesting because over time, the promise here is that we can actually see the cognitive changes, if there are any, in a particular subject. The access part of it is because now we can somebody can self-administer these tests and create the results, and we can actually grade them online. By grading, the auto grading just simply means if you gave a correct answer, it can give you feedback that you're giving a correct answer. without having to have a person telling you that, as well as the fact that it is digital makes it a lot more accessible for people to try it out by themselves. There are few other aspects of accessibility that I'll go into a little bit that we still have to work on. But once we have that, it makes it a lot more accessible for people all around the world to try it out and keep trying and keep using this application. And as a result, we can keep collecting data on from there. So, we don't lose anything when we move to digital. We in fact gain a lot of additional aspects when we take these tests digital. They can be self-administered. People can stop and take a few tests today and take the rest of them tomorrow. So you don't have to do it all in one sitting. You can maintain the state of how many tests they have done, and you can finish all the tests, and then 3 months later you can come back and take these tests again. So there's a lot of affordances like this that the digitization actually provides you, and that self-administration provides you when you try to build such an app. So just to give a summary of the project so far, as I mentioned, it's a complex project where we had to go from building the software application architecture which we are very new to, and as we took this project over in 2019, it was a very new thing for us to look at DevOps, all those things, as well as try to figure out what the design is, what the HCI elements are. And we did a lot of user testing going back and forth especially when we were changing the test from being proctored to being able to self-administer those tests. I think we did a lot of UA testing as well. And then ultimately we got ready to go and do in-field testing with our new application. And that's when actually the COVID happened and it was a lockdown. And then we resumed remote testing. So we established a remote testing protocol and we did that. So keeping that in mind, the project so far we have released 6 versions of the apps. We have roughly 150 individuals tested. These also include the people that were tested prior to this version of the app. There are now 2 versions of the app, a previous one that you need a proctor to help you do the testing, and the current one where you can do self-administration. Post-COVID, we decided a remote testing protocol. We built a lot of videos and guidance for people to be able to do the testing, and 2 clinics are involved in this testing. So when we do this remote testing, there's a whole process that we do now for this remote testing. And now I think we can do in person again. But there was for a year or so, we were doing these remote testing. And we were working with Chan Lim and another doctor to actually make sure that we can deliver those tests, collect the results in a reliable way, and find the subjects that we would like to test there. So this has been post 2020 factor, where in October 2020, we were able to fully design our remote testing protocol. In that protocol, we have patients in the clinic that we screen based on criteria decided by the doctors. And we expanded the sort of our IRB to include multiple clinics as well. And after that, we started working towards collecting the data and analyzing the data, and also improving the application so that we have better data collection systems right now. So post 2020, has been our progress. There's always the pre-2020 and the post-2020 in this world. And significantly, our way of thinking and our way of working with this application has significantly changed since then. So when we do remote testing protocol, we select the participants, recruit them from the hospital. We contact the participants and we deliver the testing materials. And once the testing materials are delivered, they actually do the testing in-house, inside their house. And we support them through a video call, a Zoom call, much like this. And then once they're finished the test, we collect back the material. And the data is already in the cloud. We just have to deliver them the iPad and bring that back for us to do the testing. So there is a protocol that we established. Now you may ask, why do you have to deliver the iPad or anything? Wouldn't it be that they can get online and do this? So that's our next phase as well, where we want to make it generally available, and we haven't reached that level yet. So I just wanted to give a very quick preliminary view into the kind of data that we are collecting. And I've been talking about this and kind of analysis and the clues that we can get from the so far limited data that we have, and what are the challenges that we're going to face going forward as we are building this more. So as I mentioned, if you just take the Trails example, I'll just walk you through the Trails example. If you just take that example, as somebody is trying this test, this is an actual example of somebody trying this test where they're connecting different bubbles in the sequence of number, alphabet, number, alphabet. On the left-hand side, I'm showing the data that we are actually collecting as part of that. So we are collecting all the coordinates. If they do pause, we also have the, I think, move to collects the data about whether they're moving to the different part of the screen. But we actually collect all the sort of the coordinates of their movement, so we can actually recreate the image that I'm showing here in the on the right-hand side, as well as we collect a fine-grained data about which path they got right. So for example, did they get 1 to A right and A to 2 right, and so on and so forth, as well as time in milliseconds that took them to finish that part of the test. So this is the level of data that we are collecting for each particular test and each particular individual. And this is just one test. So forward span or backward span and digit span, all of them have these timing measurements. And as you can imagine, getting those timing measurements exactly right and making sure we can get those precise was actually one of the challenges that we had to solve as well in the back end. So once we have that kind of data, what kind of analysis can we do? I mean, right off the bat, we can start to analyze, like, what was difficult? Did the difficulty level significantly jump after a certain stage? How much time people do take? Does the data even make sense? So in this case, what we are showing here on x-axis is the step in that path. So 0 to 1 is the step between when somebody takes the time they take to draw from 1 to A. That's the first part of the path that they draw. If this path actually has 10 alphabets and 10 digits, right? So now we are taking the average time across all the subjects that we have data for this particular test, and we are trying to plot that to see if the data collection itself is making sense. And here, as you go along the path, this cumulative time obviously increases, but we also see sometimes some jumps in terms of after a certain difficulty level. We are seeing, after a certain path, after a certain amount of bubbles that you have connected, you also start to see that more time is taken to do the last part. We actually have data post 20 as well, but it's very noisy because we don't have enough subjects there. But we do see a significant jump, but we didn't plot it here because there are not enough subjects there. So once we get enough subjects, then we will be able to show if there is a significant jump post 20, which is once the path is 20 long, there is even more time, like the time it takes to do the last part is higher than the time it takes to the first part. So now we can sort of analyze. This was not possible in pen and paper. We can analyze, we can look at the data, and we can try to analyze, like, what are the breakpoints in this test? How can we design tests with ultimate goal of saying, can we create an initial test that is quick enough, that doesn't take that much time, is less stressful, and people and be able to predict the results. So one way to do that and formulate that as a machine learning problem is, can you take for the first 4 steps in this test, can we predict the ultimate time that they will take? Can we do that? And if we can, and if it falls within a margin, then maybe they don't have to take the test. They can continue to take it according to their wish, but we can stop saying that, you should be fine, you can move on with your day. So can we do such improvements? Can we provide such sort of ability to stop tests if they don't want to take it, and if they're just taking, and we find that their result will ultimately have no, will be within the bounds that we determine with our clinical collaborators. The second question we ask is, are the test results correlated? Sorry. Are the test results correlated? So here we are taking for all the subjects the time that it took to do the trails test, which is that connecting those bubbles, as well as the forward spatial span test, which is where you blink in a way, certain squares into green, and then they have to tap them in sequence. And the backward spatial is where you have to tap them in reverse order, which is actually even more harder. I found those 2 tests the hardest to actually, because you have to remember which ones flashed, you have to remember how do you, the sequence, and you have to repeat that once they stop flashing after a certain amount of time. But as you can see, there's actually no correlation between them, the time taken between the trails test as well as the forward spatial span test or the backward spatial span test. So these are the idea being, if some tests are correlated, can we skip one test if somebody excels in one of the tests a lot? Now, there is also this problem that we can't do that for all the tests because, as you saw, these tests are doing, evaluating different cognitive functions. So not all of them are evaluating the same function. So we can't actually skip the test. But that's where we are working with the clinicians to figure out how do we formulate that machine learning problem, which itself is a big challenge, such that we can create a shorter test and also maybe skip some tests. The second correlation we are trying to see is, as you can imagine, there is some amount of correlation between the total forward spatial time taken to do the forward spatial test and the backward spatial. This does make sense because those two are very similar tests. You're being flashed certain squares, and then you're repeating in one time you're repeating in the same sequence, and then the other time you're trying to do the inverse of the sequence that was shown for you. So it makes sense it's correlated, but when we check the numbers, it's not that correlated. It appears correlated, but I think it's like 0.54 and such, it was correlated. So these are the kind of data that we can actually collect and try to analyze these test results and try to figure out, how can we design tests that are simpler, faster, and can be taken in routine. I would say, if you say 10 being where we would be sort of like really good at publishing those results and they're clinically validated, we probably are at 2 right now. We still have a lot of work to do in this area in collaboration with our sort of clinicians to figure out how do we achieve that goal that we set out. So what can we do with machine learning, as I've been alluding to? In short term, we can try to improve sort of the test accuracy, reduce the test times length. If simple tests are giving results, can we not have to do them, sort of larger tests that take more time? Or can we start with a larger test and stop halfway through and say, oh yeah, you should be good. And maybe create different combinations of tests and create data-driven adaptive tests where we are trying to figure out, as I said, that how do we increase the difficulty level for the test and how we take the feedback of the test results so far to decide what difficulty level to provide for the subject. In long term, ultimately, we do want to achieve a 2 to 5 minute battery of tests. So something that takes a battery of tests that takes just 2 to 5 minutes. Now that's a very ambitious goal, and that's where we are trying to head towards. We want to work with clinicians to figure out how to do diagnostics tests. So these are not diagnostics tests right now. These test results will be a recommendation to go to the doctor. We don't anticipate saying that this is a diagnosis right now. So that would be one of the goals, as well as we want to be able to serve and design to be able so that people can use at home. So if anything that the pandemic taught us is that we need to be able to design these systems so they can be used at home. There's still a number of accessibility issues if somebody has to use at home. For example, colors, if you use colors, if you're using audio, if you want to have wide scalability for people to use this, we would have to figure out, creative ways to change those tests so that they're not simply dependent on colors or audio, and in a way disenfranchising a lot of people that can actually cannot do those things, cannot recognize colors or cannot listen to the audio. So just to give a sort of insights into what are the next steps for iBoca. So the challenges we did face, as I mentioned, was converting all the tests so that there is an ability to self-administer. We faced a lot of challenges with data analytics, but that's a domain that I'm very comfortable and I've worked in before. There was a lot of data collection challenges. As I mentioned with COVID, we just got stuck. We had to change our protocols. We had to invent new protocols, work with doctors to figure out how we can now do this in this new world. Now, actually, we can do in-house, in-clinic testing as well. So now things are coming back. We had the challenge of software architecture. I think we built everything in a piecemeal basis, so we had to revamp everything to build a software architecture that's much more agile, and it's still in progress. But these are the challenges we have ability to solve, or we have solved part way, and we know what will help it solve fully. There is the challenge of general availability of apps. So we designed it for iPad, so now we are actually sort of reworking the architecture to be able to make it available across different devices, whether it's iPad or iPhone, or as well as a website. So, and there's a way to do that, but we are trying to do that. The next two challenges are clinical in nature. This is the biggest, probably the biggest and most pertinent challenge for this to be successful, beyond all the other data analytics and software architecture, is collecting baselines. So what is normal? I think we had a lot of ideas as we went along. How do we collect normal, and how fast can we collect what is normal? And the second is that any test we do, we would have to figure out a way to validate them clinically. What that means is that there's a lot of confounding factors that we may have introduced by digitizing them, and we may have introduced by changing them to self-administration. To clinically validate that would mean that we would have to do the same test in clinical settings, and then try to figure out for who we know the results, and validate if the app is not getting influenced, or the results are not getting influenced with these confounding variables. And one of the confounding variables is the ability to use a digital medium. Like a lot of people that we want to use a test may not be able to use the digital medium, or may not be adept in using digital medium, or not used to it. The other challenge that we have is just the formulation of the machine learning problem. And that goes hand in hand in terms of like whether we can formulate that problem and at the same time validate that clinically. So that is also a big challenge for us. Can we sort of, for example, one example problem could be, can we predict test results as the test is proceeding? This is what I've been alluding to, but we can create and formulate such problems. And with machine learning, we can even try to predict it, and we can also try to validate it with the data itself. But ultimately, we also have to go with clinical validation again, to do that in controlled settings and validate that the machine learning model and the prediction algorithm that we have designed to do that actually is valid clinically under those controlled settings. So those are the couple of challenges we still face as we are building this application up and taking it across the world. One of the interesting things, as I mentioned early on, is, I always worked on data when it was handed over to me. So this is the first time I have ability to collect, guide data collection and influence data collection. And that brought another set of challenges, as you heard throughout my talk. But still, this is the first time I have that ability, and my team has that ability to enable that. So that means that we can control and we can reduce the data collection bias at the very outset. So a lot of us in machine learning used to wait for the data, and once we have the data, try to collect the bias by, a lot of data debiasing techniques, or trying to do a lot of sampling techniques and so on and so forth. But now we can actually figure out what are the elements in this whole chain of building the app, collecting the data, putting the tests out. What are the things that we are doing that could be changed and to reduce data bias and maximize adoption? One other example of the bias is language bias. There is actually, many of these tests have language bias. I personally took, so the naming pictures test, they show you some pictures. Sometimes it's as simple as umbrella. Sometimes there is some axe, or there are different things. But I personally, some of those pictures, I know what it is, but I don't know the actual name for it. And there is no way, when you don't know the name for it, you can't actually even search on Google, right? So there was that challenge that I personally had, and that actually creates a bias and disenfranchises people who cannot take that test, because there are certain things that they cannot name in English. So can we solve that problem right away in our test itself? So there's still issues like this that we can actually influence at the very get-go. And that's one of the things that we are working on. So there's a number of things when we keep ML in mind and keep the data collection, data analysis in mind, we actually try to influence the data collection at the very get-go to solve those problems, and not wait for analysis to solve those problems. From from general availability point of view, we also observed a lot of challenge in terms of engagement. So, people start tests, but then, they get bored or they don't want to, do the rest of it. And they're sort of, sometimes some stress could be actually stressful. Tests could be stressful. So we also noticed that. And I personally, actually, I took this test in front of a couple of other faculty and I was getting a little bit stressed because I felt like, I'm being watched in terms of how well and how fast can I do the test. So regardless of that, in general, some of these tests could be actually stressful. So one of the things that we are working on and thinking about is how do we make these tests less stressful, and how do we make the engagement even much more fun? One of the ideas that we have is integration with the Zoom, and also integrating sort of grandkids and grandchildren. My parents don't want to talk to me, they just want to talk to their grandchildren. So they will never listen to me if I ask them to take the cognitive test, but they will definitely listen if the grandchildren are working with them to take the test or guiding them to take the test. So that's one of the things that we can try. So all in all, my conclusion from this project was it's complex, but when you get into the early stages, the sort of the options for you are wide open, and you can influence a lot of things in the whole design, development, and data collection life cycle, and then ultimately make machine learning sort of more fruitful. The flip side of that is that machine learning won't come as fast as you would like it to come. So it just will take a lot more time to get to a point where you have clinically validated machine learning results. So if you're in one of these projects where you're doing end-to-end, it's worthwhile to be patient. The benefits at the end are huge and are very impactful for the society. So with that, I think I'll stop. I don't know if I took the whole hour or much less than that, but I wanted to.
Thank you so much, Kalyan. That was fantastic. I love this talk. And when I was paying attention on how like you bridge those two generations, like how to engage with your parents, with the children, right? I thought that was extremely smart. It's and it's all about gaming and engaging, right? This is excellent. So let's see if we have some questions. Usually the talk should finish and with Q&A at 5. So we still have a few minutes where we can run through some questions. Let's see if we have some reactions. Some folks want to know more about some details about your work. But thank you again. It was an excellent talk.
Thank you. I'm trying to think. I think someone mentioned something. So
yes, there was on the chat. There was a that was Anna saying.
Maybe Anna saying, yeah, maybe
Yeah,
this is trivial, but what might be notable distinction between iBoca and Mocha's own digital app and current future offering? Is it primarily the fine-grained data collection? That's a very excellent question. I think I haven't looked at the Mocha's own digital app, but I would check it out. There are a couple of other applications that are doing this as well. It is fine-grained data collection. It is the number of tests that are available. It is the ability to do self-administration. And as we improve our data analysis and put machine learning and create machine learning models, we will be able to put it back into the application itself and guide the application in terms of testing individuals. So I think that is a sort of a big differentiator for us. At least that's what we are hoping for. But I'll check out the Mocha's own digital app as well.
And I guess adoption, Kalyan, this is one of the challenges here, right? Like how you bring more people to use these tools, how you improve the model, and I mean, you've been talking about this, but I guess it's not so much on the technology side of things, but more on the social. How do you see this as well?
Exactly. I think it's not so much the digital, although the digital could be, the technology could be enabled if we put our mind to it to enable and solve those problems. But there is a lot of problem in terms of solving the adoption, wide-scale adoption, getting the demographics, like making sure it's available to all demographics. There's a lot of issues that we have to solve to make sure it's available to everyone. And then also making sure that the communication is appropriate such that it doesn't, it only promises what it can deliver. So it doesn't say it's a diagnosis. It is actually saying that this is something that, will give you a score, and of course, work closely with clinicians to come up with what that score is. And then it just gives you a recommendation. So, and if you promise more than that, it should be validated in a clinical setting. So that is the bigger challenge, those adoption, and then incrementally in lockstep, we have to grow this, not by just, we can solve with machine learning, we can predict anything, but, I heard some joke the other day that eating chocolate predicts Nobel Prize, but Munzer's joke, that was Munzer's joke, so I took that joke
Okay,
from
okay.
it.
That's an interesting one, yeah. Thank you.
Oh, thank you. That's all I had. I don't know if we see any other questions or.
Just see if there's any. Yeah, we can give you some time back. I think you did a good presentation, and okay. So I have Daniel Kessler is asking a question. Can you see it on the chat?
Yeah. I'll repeat the question. Many people with dementia live with caretakers. For these individuals, do you imagine there's a role that caretakers can play in helping deliver the test? Absolutely. I think caretakers, if you have caretakers available, they can help you take the test. And so the self-administration doesn't actually, mean that you cannot proctor. So caretakers can actually make that proctoring happen and encourage them and get the test results. And in some cases, we have actually used caretakers to actually do the testing as well. I would have to check on that, but yes, they absolutely have a role in doing that.
Excellent. Thank you, Daniel, for the question. Yeah. I guess yeah, in how you adapt this to different populations and different patients, right? Because this expands to a variety of yeah groups, society groups. Yeah.
Exactly. I think I was surprised myself that I could name, when naming pictures test came, I was like, I know what it is, but in my own language. So I don't have it in English to be able to say what the word is, and you can't actually Google search it. I guess you can type in my own language the word and look for a parallel, but it's kind of hard to do that.
Yeah, yeah. So also yeah, something to be yeah, because right now you're using this in a of course in a very English driven version, let's say, right? Yeah.
Yes. So I think a lot of work is about accessibility and making it much more accessible, and then also getting the messaging and getting the right sort of the promise and get the digital, like, so people adopt it and for the right reasons and have the data. That would be one of the biggest challenges.
Yeah. Excellent. Okay, so I think if there's no more questions, we can leave it here. Oh, and so another question, Michael Lee, does the iBook assess abstraction, similarities or analogies? Can you?
Go ahead. I don't think we do that right now. I think by that I mean that you're testing if two things said a certain way are similar.
Yeah.
Michael,
do you want to elaborate a little bit? Or if you can unmute yourself and ask the question, maybe.
Michael?
Trying to unmute him, but not sure how to do it.
No problem. I think we can.
Yeah.
I can take that question offline.
Yeah, that's a good idea. And maybe, yeah, exactly. We can, if there's anyone that want to connect or follow up, has any further question, they can always connect, whether through the website that is now on the website, the internet address, or through your email or via JClinic, we can also easily follow up.
Great.
Excellent. So, Kalyan, again, thank you very much. I appreciate really your time and your talk today. And thank you everyone for attending our seminar series.